Hey everyone, Mr. Cummings here, and in this video we're going to take a look at doing this Intro to Gravity FETLab where we can move these objects and see a force that's attracted between these two massive objects. So we're exploring the concept of universal gravitation, where if you have two objects with mass in the universe, they tend to attract each other. So just like the sun attracts the earth, or the earth attracts the moon, just like that, an object like you or I will attract every other object with mass. But we don't normally see those interactions. We typically see these interactions on a much larger scale. So that's what we're going to look at today. So we've got our simulation set up here. Let me turn the sound off. So the first thing I want to do to set this up, we're going to take a look at doing the distance and force measurement. I want to move this blue mass over here all the way to the left. And I want to take my meter stick and I want to center it so my zero mark is on the dotted line. And that way it makes it really easy for me to take my distance measurement. Also here, the forces that we have going on, the 0.000, all of that stuff, it's going to be easier to read and to input in our Vernier graphical analysis if we switch it to scientific notation. So we're going to do something like this, and so I'll show you how to put that in. So let's start small and then gradually go bigger. So let's start at these two being 2 meters apart. So we'll just enter 2 as our first, and then our force here is 6.67 times 10 to the negative 7, meaning we move the decimal place to the left 7 spaces. So you can see that that's what it would look like in decimal. So here's scientific. The way I want to type this into Vernier graphical analysis is I want to do the same thing where 6.67, let's actually go over here, so 6.67, and then I want to use a capital E to represent the times 10, and then I'm just going to plug in the exponent there. So 6.67, E represents times 10 raised to the, and then the negative 7 is the exponent here. So if we hit enter, then it'll take care of all the zeros, and it's really easy to take our data. So we're going to continue to do that. We're going to move this incrementally. So maybe this is 2.4 meters, 2.4, and then we get 4.64, and then E to the negative 7 again. And so we'll just keep taking data like that until we fill this up. In the next video, we'll show you how to